Okay, so in this video, we're going to review some 3.1 to 3.4. So here's a nice chart you might want to get into your notes. So it goes through the different classifications of systems of equations. Consistent and independent means there's exactly one solution. The lines cross. You could even draw a little picture like this. They cross at one point. And this would mean the slopes must be different. And then consistent and dependent, it means it's the same line. Okay, and then same slope and the same intercepts. The same exact equation. Same equation. Infinitely many solutions. And then parallel lines, same slope, but they would have different y-intercepts. And we call this inconsistent. So then we've got a little matching, or a little 4 problems where we tell which one is which. So this is the consistent and independent because there's exactly one solution. This one is inconsistent because it's parallel. And then we should be able to tell just by the equations without having a graph. So just get this into slope-intercept form. I'm going to add y to both sides. Okay, so we get, and then subtract 3. So 5x minus 3 equals y. So here we see they have the same slope, same y-intercept. So these are the same equations. This would be consistent and dependent. The lines would coincide. This one, you can see if you multiply, let's see. Let's just get them into slope-intercept form. Y equals negative x plus 6. This, I'd have to subtract 3x on both sides. So you have 3y equals negative 3x plus 3. Divide both sides by 3, and we get y equals negative x plus 1. Negative 3 divided by 3 is negative 1. And so we compare, we have the same slope, but different y-intercepts. So these would be parallel lines. It's just like this situation. Inconsistent, and there's no solution. So which one of these is graphed? And the best thing here, again, just get these in slope-intercept form. So solve for y. This one, I'm going to add y to both sides. So x equals 2 plus y. Subtract 2. So I get x minus 2 equals y. And here, just subtract x on both sides. Y equals negative x minus 4. Is that one of these? Well, this is the y-intercept would have to be negative 4. So it can't be this one. This one would have a y-intercept at negative 2. It can't be that one either. So then this one, y equals x plus 2, that could be this line. Slope of 1, because we're rising 1, running 1. So this line is y equals x plus 2. And this other line does have a y-intercept at 4, but it has a negative slope. So actually a better way might just be to try to figure out the equations of these two lines. We already have this one. And this one would be y equals negative 1x plus 4, because we're going down 1, right 1, down 1, right 1. That's a slope of negative 1. So look for these two equations somewhere. It's not this one. This one is x minus 2. It can't be that one. So this one, this would be y equals negative x plus 4, which is the green equation. And this one is if we just add x to both sides, y equals 2 plus x, and subtract 2, then we have, no, just leave it like that. Y equals x plus 2, which is the red line. So it's got to be C. Okay, now we're going to solve using any algebraic method. So elimination or substitution. So here you could use elimination, try to eliminate the y's, or try to eliminate the x's. But another way, if you have both equations in slope-intercept form, you can substitute one part into the other part. So if y equals 2x minus 4, then this y also equals 2x minus 4. We can replace or substitute 2x minus 4 for this y. And now we have an equation just with x. We can add 6x to both sides and add 4 to the other side. So we get 2x plus 6x is 8x. These cancel out. These cancel out. And 20 plus 4 is 24. And we see x equals 3. And then we plug back in. I'm just going to use the first equation. Y equals 2 times 3 minus 4. So y equals 6 minus 4. So y equals 2. So that's using substitution. Could also use elimination. Just do equation 1 minus equation 2. And so you'd have y minus y is 0. 2x minus negative 6x is positive 8x. And negative 4 minus 20 is minus 24. And then add 24 to both sides and divide by 8. And you have x equals 3, just like we had before. So different options on that one. The second one, probably not going to want to use substitution because none of the variables are by themselves. And if we just add the equations or subtract, we're not going to cancel anything out. So this is a situation where we're going to have to multiply both equations by something in order to get the coefficients the same. So I'm going to multiply this one by 2 and this one by 5 because then I'm going to eliminate the y's and we'll see what happens. So this one, 2 times 4x is 8x, 2 times 5y is 10y, 2 times 7 is 14, and then 5 times 3x is 15x, 5 times negative 2y is negative 10y, and that's why I multiplied the way I did, to cancel these out. And 5 times 34, let's just do that over here, 5 times 34 is 170. Okay, now we're adding these equations together to cancel these out. 184, and then we divide by 23. So 184 divided by 23, I'm going to get my calculator out, and that's 8. So x equals 8, and now I can plug into any equation. I'm going to use the top one. 4 times 8 plus 5y equals 7. So 4 times 8 is 32. And I'm going to subtract 32 on both sides. So we get 5y equals negative 25. And divide by 5, y equals negative 5. Okay, systems of inequalities. So with the shading, again, I think a better way to do this might be to just figure out the equations of these lines. This one has a y-intercept at 1, 2, 3, 4. That's 4. And the slope looks like positive 1. But maybe not exactly. It's kind of hard to tell without the grid. And this one has a y-intercept at 1, and it looks like the slope is negative 2. So maybe this is y equals negative 2x plus 1 for this one. But we're shading below the line, so I'm going to have to go less than or equal to shade below this line. We're shading above the other line, so this is going to be y is greater than or equal to, I'm going to guess x plus 4, because it looks like the slope is up 1 over 1. So 1x plus 4. So which one of those do we have? Well, here's y is greater than or equal to x plus 4. Here's y is less than or equal to negative 2x plus 1. So it's got to be this one. Okay. And another one. This time we've got strict inequality, so it can't be this one because that's not a strict inequality. These are dashed lines. This one's going to be easiest to figure out. Y is greater than 1, 2, 3, 4. Greater than is above. But they all have that, so that's not going to help. This one, let's just get in slope-intercept form. This is going to be y is greater than negative x plus 2. Is that this line? No, because this is a negative slope, and this has positive slope. So it can't be this one. could be these, but this is not a strict inequality, so it's got to be D. Y is less than x plus 2. Less means below the line. And here's the y-intercept is 2 and up 1 over 1. So that's the slope here. So it's D. Okay.